Let's see our next inequality. Again, we have rational inequality. It means first we have to find the domain. When we have to find the domain, it means we have to check when this denominator will be 0. So we have x squared minus 5x plus 4 equal 0. So we have quadratic equation. To solve, we have to factor or use quadratic formula, but I think we can factor this. So it will be x and x because we have x to second power, and we have to find two numbers which multiplying by each other give me positive 4, and when I add them I will have negative 5. It will be negative 1 and negative 4. The left side will be 0 when one of these factors will be 0. So x minus 1 will be 0 or x minus 4 will be 0. So we have to solve these two equations. We have x equals 1 and x equals 4. So our domain will be all real numbers excluded 1 and 4. Now we can come back to our inequality. Let me copy. I have x squared plus 5x plus 4 over x squared minus 5x plus 4 is greater than or equal 0. Because we have fraction on the left side, we have to multiply both sides our inequality by the denominator raised to the second power. Minus 5x plus 4, and on the left side x squared minus 5x plus 4 to second power. Why I put square? Because I want to be sure that this expression is positive, because we have inequality. When I will multiply by negative number, I have to change the direction of our inequality. So when I put square, I'm sure that this expression is positive and I don't have problem with direction of our inequality. So we see our denominator will cancel with the square, and we have x squared minus 5x plus 4 times x squared plus 5x plus 4 is greater than or equal 0. Now we have to make the left side equal 0. So we will have x squared minus 5x plus 4 times x squared plus 5x plus 4 equal 0. We have multiplication on the left side. This left side will be 0 when one of these factors will be 0. So x squared minus 5x plus 4 will be 0, or x squared plus 5x plus 4 will be 0. This equation we solved before. We have roots x equals 1 and x equals 4. So we can just copy this. We have x equals 1 or x equals 4. And we can factor this expression will be x equal 0. We have to find two numbers which multiply by each other give me 4, and when I add them I will have positive 5. It will be 1 and 4, of course. So now when this left side will be 0, when x plus 1 will be 0 or x plus 4 will be 0. So we have x equals negative 1 or x equals negative 4. We have roots. Now we can draw number line x and we can place our roots. We have negative 4, negative 1, 1 and 4. Next we have to check how many times our roots repeat. We see that we have content of this parenthesis raised to first power. It means negative 1 repeats 1 times. The same is with x plus 4. The power is 1. It means negative 4 repeats 1 time. Now we have to check how many times repeats 1 and 4. Let's go to our domain. We rewrite our quadratic equation to 2 factors, and x minus 1 is raised to first power. It means our 1 repeats 1 time, and x minus 4 is raised to first power. It means our root 4 repeats 1 time. Next, we have to check the sign of coefficient next to the variable with the highest power. The highest power will be x squared times x squared is x to 4th power. The coefficient is positive 1. It means we have to start to draw our graph from positive value. It means above our number line x. And because 4 repeats 1 time, it's odd number. It means we have to pass 4 and we are going to next root. 1 repeats 1 time. It means we can pass this root, and negative 1 times, negative 4 the same. So we just passed this 4 roots. Next, we have to come back to our domain. We exclude 1 and 4. So I will draw circle on 4 and 1, and because we have sign greater than or equals, it means negative 1 is included and negative 4 is included. And now we have to find the value greater than 0. Greater than 0, it means above our number line. This part is above, this and this. So we have 3 intervals. From negative infinity to negative 4, close on the right side. Next interval is from negative 1, close on the left side, to 1, plus open interval from 4 to positive infinity. So this is our solution.